Hello guys, welcome back to my channel D's Tech World. Here Darshan is going to explain about the memory management and struggles. We are going to explore about the memory management and its struggles to employ the computer systems to effectively allocate memory and manage optimally previous memory to the resources. Going to further, we are knowing about the background of the memory where what is managed by the memory and how it works. Managing the heart of computer. Memory management is a crucial aspect of computer systems, optimizing operations and optimizing it. The responsibility for allocating, deallocating memory to run and program and processes, enhancing the optimizing performance of the stability of the computers. Ecosystem. Memory ecosystem is more reliable or referred to than RAM, which is random access memory, is a virtual component acting as a temporary storage space for an acting data and program instructions during the execution time. Importance and effective memory management. Enhancing the performance. Enhancing the memory allocation and utilizing the leads to perform faster program execution and improve the overall system performance. The memory provided by the storage can improve the process of enhancing or executing the program while it is performing a crucial part. Stable and reliable. The proper memory management provides an confidence and conflicts, errors, and crashes, enhancing the system's stability and reliability. The main role which is performed by the memory, allocation and deallocation, which I said before, allocating means giving a memory to the storage or storing it. Deallocating means pushing out or taking from the memory. Where the allocation when and process requires memory, the memory management allocates the specific amount of space it to it to enhance sufficient resources and execute it. Deallocation. Upon program terminating or when the memory is no longer needed, the memory management reclaims the allocated space, making it available for reusing. Swapping. Swapping is a concept which is used for memory management and to sort it. Here we are going to swap the storages or the processes which are going to being performed by the user to store into the secondary memory and retrieve it when it is required. The swapping is a process which involves the storing of processes from the main memory to the secondary memory and vice versa, and this is operation is called as swapping. Need of swapping. Physical memory is insufficient to hold an active processing. Swapping helps to manage the memory and contrast by moving the inactive and less frequent using processes to the secondary storage. Hence, here they are going to denote that if the processes or the tabs which we usually open from the computers like Microsoft Edge, Chrome, or in that we are going to open Amazon for shopping, and which we are going to search the products and the top trending products in Google, and which we are going to make many processes during the selection or shopping time, which we many tabs we are going to use many tabs like 4 to 5, where we going to open a single not we are not going to open a single tab, we are going to use a multitasking topics where we are going to use an sufficient data where we are the memory uses or changes accordingly, where the present page or the tab which we the user want to use, it will be displayed and the other tabs will be stored in the secondary storage to enhance the primary storage and reliability and stable of the system, which we can see in the second picture where the here the operating system which operates A tab or the A process, which is again enhanced or added with B processor and then the C processor, where the processor A is not required, and according to time we are going to add D so that the A processor as required more space, so we are going to move A processor to the secondary memory, and we are going to add D processor to enhance the performance of the operating system. Then we are going if we want to add a processor, the unrequired processor will be sent to the secondary storage and the A processor will be added. This is the inner part of the swapping where it involves unknowingly for the users in the present generation computers, where the swapping process can be seen in the memory often monitors memory of task manager, where we can see the swapping used, means the memory used for swapping is 5 GB in the particular computer. Moving to the further, swapping policy and FIFO, LRU optimal. FIFO, first in first out, which is an we can say it as a stack. Stack is a first in first out process, which is a data type where involves an first element which in the line, or first element inside the stack will also execute the first when pushed out or taken out. Here also the oldest process in the memory is swapped in out from first. Means the first process which we are going to send into the memory will be swapped first from the memory, regardlessly for the active level. Means to perform more efficiently and maintain the space, the operating system follows FIFO, first in first out policy. LRU, least recent used user, the process that has not been accessed or recently in and swap out first, accu- assuming assuming less likelihood for a future use. Means it takes an analysis where the tab which is open is less in use, which will be stored into second memory so that it can enhance more space in the operating system to use another process for an future perspectives. Optimal. Optimal is a process a, that would not be used for a long time, and the future requires some future knowledge of optimal enhancement. Means they are going to say that the optimal of function use means tab space using is efficient for swapping the memories. Going further, factors affecting the swapping, where we are going to see about the swapping space and the disk speed and the performance actively pattern, where the speed which we are can be said as an SSD speed, which we are going to see at 3200 and something in our recent SSDs, and the swapping space which we are going to see in the SSDs, which will enhance from the disks, are more reliable, but they are still processing, which requires some time to process and accumulate the more processes into it. And coming to the process actively pattern, swapping the performance in an heavily influenced by a pattern of activing and process within a frequent swapping cycle can lead to a performance degradation. Means frequently swapping the cycles means opening the frequent tabs one by one, means opening A tab and go to B and C, D, and again making a cycle can make a degeneration of performance in an or degradation of the performance in computer. Going further, we are going to know about the thrusting and causes of sequence. Causes in thrusting occurs when the system spends an excessive time swapping processes in and out of the memory, leading to a systema- dramatic decrease in the system performance. Means frequently, as I said, moving on a circular process of A, B, C, D processes or the opening the tabs make and get the system degradation. Here, the consequences of spreading and led to the sequence performance of degradation, as said before, are the most system resources are assumed in and swapping, resulting in a poor experience of systems in stability, which also occurs in the system instability by consuming more time and resources of the system. Technically to avoid the thrusting, increase the memory, adding more physical memory and reducing the needs of swapping effectively and migrating the thrust. Using the optimal tabs which we are required, not unnecessarily opening the tabs may reduce this thrusting, and also to increase the RAM, means which we are going to suggest as 16 GB nowadays, where the 8 GB is the lessest form or the minimum which required for an particular student or the user, 8 GB, and the minimum using is 16 GB, and maximum you can go until the utmost of the processing required. And the processing of optimization, Prioritization acts as a process, enhancing the frequently used process remaining in a memory can reduce in swapping frequency. Using the process of optimization, we are going to frequently use a program to remain the main memory to reduce the swapping process. And the process reducing reduction. Minimizing the process size can reduce the memory requirement and improve the performance of the system. Going to the pages and segment mechanism, where as I said, we are going to divide the processor into small segments called as pages and segments to improve the performance of the systems. By this I can say that I've concluded by the struggles of the memory, where the allocating and deallocating and replacing the processes during the execution and storing them and what are the types in it, and all of this video is ending here, and I thank you all for listening to me for this precious time. Thank you all.